Welcome to today's lecture on cooling towers and heat exchangers. We will be exploring how these crucial pieces of equipment transfer heat, maintain plant efficiency, and how to keep them running smoothly. To start, let's look at the two main ways heat is transferred. In direct contact exchange, the hot and cold fluids actually mix together, like water and air in a cooling tower. In indirect contact, the fluids are separated by a solid barrier, such as a metal tube or plate. Cooling towers are specialized direct contact exchangers. They dissipate heat, conserve water, and supply low-temperature cooling water to maintain a plant's thermal efficiency. They do this by spraying warm water over a wide surface area while air flows through it, causing evaporation. How does the air get through the tower? Well, natural draft towers rely entirely on wind and natural air currents. They are simple but depend heavily on the weather. Mechanical draft towers, on the other hand, use fans to guarantee consistent airflow. Within mechanical draft towers, we have two styles. Forced draft uses a fan at the base to push air in, while induced draft places the fan at the top to pull air up through the falling water, creating a highly efficient counterflow. Moving to indirect exchange, the shell and tube heat exchanger is the workhorse of the industry. It consists of a large outer shell packed with a bundle of smaller tubes. One fluid flows through the tubes, and the other flows around them inside the shell. Inside the shell, you will find baffles. These are crucial because they support the long tubes to prevent sagging, and they force the shell side fluid to zigzag. This creates turbulence that dramatically improves the overall heat transfer rate. There are a few main designs. Fixed tube sheets are welded in place, making them cheap but hard to clean. U-tube designs allow the entire bundle to be removed and handle expansion well. Floating head designs have one end that moves freely, perfect for extreme temperature changes. Another popular indirect design is the plate heat exchanger. It uses a series of tightly packed corrugated metal plates. The hot and cold fluids alternate between the plates. This creates massive turbulence and highly efficient heat transfer in a very compact footprint. A unique variation is the spiral heat exchanger. The plates are rolled into a coil, creating a single, long path for each fluid. This true counterflow design creates a self-scrubbing action, making it fantastic for handling sludges or dirty fluids. When dealing with gases, which do not transfer heat as well as liquids, we use extended surface exchangers. These have fins attached to the tubes to increase the surface area. For low-flow, high-pressure situations, simple tube-to-tube or double pipe exchangers are often used. Over time, all heat exchangers get dirty. We call this fouling. Buildups of scale, sludge, or algae act as insulation, ruining efficiency. To fix this, operators use chemical washes, high-pressure water jets, or mechanical rotary brushes to scrub the tubes clean. Besides fouling, vibration from fluid flow can cause tubes to crack or wear out. When a leak is suspected, technicians perform a hydrostatic test. By pressurizing the shell side with water, they can easily spot which tubes or joints are leaking and need to be plugged or re-rolled. To wrap up, we have covered the differences between direct cooling towers and indirect heat exchangers, like shell and tube and plate designs. Remember, choosing the right equipment and maintaining it properly is the key to a safe and efficient plant. Thanks for watching.